characteristics of a mineral. Go ahead and raise. Go ahead.
Color, luster,
Perfect. That's kind of how you test, how to determine minerals, that type of thing. What are some other ones?
Solid.
Yep, generally. Yep, so they're inorganic solids. Anybody else?
Naturally occurring.
Yep, naturally occurring. Did you have one?
And
Go ahead.
crystal structure.
Yep, they're crystal structures. Anybody else? Yeah, so the four kind of main things are that they naturally occur, they're crystal structures, they're inorganic solids, and then they have a definite chemical composition. And then from yesterday's lab, do you remember kind of what the objective of it was?
Identify minerals.
Yeah, kind of just define the identification of minerals. And then what were some of the things that you did? You kind of mentioned them already to help identify those minerals. Yep, so the streak. So how did you test streak?
you use the streak plate and you basically rub it on the streak plate.
Uh-huh.
And if the streak didn't show up, it was colorless. So it was too hard for the streak plate.
Very good. What was another one of your tests you did? The luster. And then what was luster? What was kind of with that? Anybody else? No? Anybody? Go ahead.
How it reflects light.
Yep. So it's going to be if it's like metallic or shiny, that kind of thing. And what was the last thing you did? Color. Anybody have color? That was the easy one. It's the color of it. So now go on your computers and you can go ahead and answer that question. So how do you test the hardness of a mineral? And it'll come up here. I think you need 17 answers. So how do you test the hardness of a mineral? Tap it with a mineral hammer, you do the field hardness test, you bite it, or you do the lab density test. So go ahead and click A, B, C, or D on your computer. Perfect, looks like we got everybody. Do you want to click the I thing? Alright, so this kind of tells us how we did as a class. Field hardness test is the correct answer. Most of you got that right, good job. Tap it with a hammer. Kind of right, but a hammer, you can hit a diamond with a hammer, and if you hit it right, it'll still crack, even though diamonds are the hardest mineral you have. So kind of varies there. And then lab density test, we're testing the hardness of it, not necessarily the density. So that was good. You can go ahead and shut your laptops now. We'll use them in a minute though. And then if you want to switch to PowerPoint. So we'll just start off reading. Do you want to start? And you'll just read this first one, our objective for the day.
After this lesson, students will be able to explain how minerals are identified.
Perfect.
Measure how easily a mineral can be scratched is its hardness.
Sometimes concept of hardness confused with whether it was not a mineral.
That's kind of what we were talking about with that diamond thing. Make sure you speak up when you talk so everybody can hear you. And we'll kind of go over this list here later, but the Mohs scale goes through like the minerals that you're testing. This is the hardness of common objects. So these things are things that you're generally going to be able to find pretty easily. Your fingernails, hopefully they're there all the time. Next one.
This list is called Mohs scale. Not all mineral crystals have smooth surfaces and regular shapes.
There are 6 major crystal systems which classify minerals according to their crystal structures.
So we'll go through these here.
Minerals in the cubic crystal system are equal in size along all 3 principal dimensions.
So the cubic one is cube.
Tetragonal crystals are much like cubic crystals except that one of the principal dimensions is longer or shorter than the other 2 dimensions.
So kind of like 2 cubes stacked together.
In hexagonal crystals, horizontal distances between opposite crystal surfaces are equal. These crystal surfaces intersect to form 60-degree or 120-degree angles. The vertical length is longer or shorter than the horizontal length.
So this one's going to have 6 definite flat sides that you'll see.
Minerals with orthorhombic structure have dimensions that are unequal in length, resulting in crystals with a brick-like shape. Minerals in the monoclinic system exhibit unequal dimensions in their crystal structure. Only one right angle forms where crystal surfaces meet. The other angles are oblique, which means they don't form 90-degree angles where they intersect. Triclinic crystals are unequal in all dimensions, and all angles where crystal surfaces meet are oblique.
So you'll see with like the triclinic one, pretty easy to remember triangle, triclinic, you're going to see a triangle in there. Go on here.
Another way to add minerals is through the breakage.
The way a mineral breaks is another clue to its identity.
Minerals that break onto that surfaces have cleavage.
Cleavage is determined already by the determinants of minerals and things.
Not all minerals have
Minerals that break with rough or jagged surfaces have fracture.
Yeah.
quartz is a mineral with fracture.
Yep. So why don't you, the first row, turn and talk to the second row. Third row, turn and talk to the 4th row. You can go ahead and join this group over here. So talk with your partners, kind of compare and contrast the differences and similarities between a cleavage and a fracture. Alright, you guys get it? Who wants to share a difference between cleavage and fracture?
So cleavage is basically, if it splits, it'll be a smooth surface, but fracture, if it splits, the surface will be jagged and rigid.
Yeah, so like a cleavage is going to be this one where you can feel it's a smooth break and it's kind of just like a flat thing. It'll come in kind of sheets, kind of like this. A fracture is going to be a little more jagged. You're not going to find a very smooth surface on here. So if you, for example, this one, if you were to drop this, it wouldn't split into perfectly straight sheets of mineral. It would break into thousands of little fractured pieces. So we'll pass these around real quick. The flat one's the cleavage and this one's the fracture. And then I think we're here for the
Some
reading.
minerals have unique properties.
We'll go back. Well, we'll start at the beginning here now. Magnetite. Yep, so magnetite is going to be this. It's also called lodestone. And this is going to be your only rock in your lab that you do that's magnetic. So on Monday when you do your lab, there'll be some staples in your hardness kit. So if you take all of your minerals and put them in here, the only one that's going to pick up the staples like this is going to be your magnetite or your lodestone. So that's going to be a pretty easy one for you to find because it's the only one that'll do that. And then smell is another way that you can identify these, and all of these things are things that you'd like to write on your paper when you're doing your identification. So if you identify it and you think, oh, this one picked up staples, then you write that down and say it's magnetic, because that'll help you identify later on. So for smell, this is sulfur, and sulfur is kind of like, have you ever been to Yellowstone National Park? You know that smell that's there, or the smell of fireworks kind of? That's what this smell is. Gotta freshen it up a little bit here. And this is a really soft mineral too. So we'll pass this around, you can give it a smell, and you can really easily smell that sulfury smell. So that's another way to help identify what minerals you have. And lastly, another property is the fluorescence of it. So some minerals, if you put them under a black light, are going to glow. So like these ones here, we'll look at them right now. They look like pretty normal minerals, right? Nothing too special about them.
Yeah,
Look pretty good.
You never know.
Good things are hard, huh? So then we'll take the black light over here. You see that, how different they are?
Whoa, what's that one?
So they look a lot different when you put a black light to these ones. So that's another way to help identify. Yeah. And then the last main property is for quartz. I think we're, so in your lab yesterday, you had quite a few transparent minerals, right? But there's only one, which is calcite, that's going to make you see two when you look through it. So that's another one of those easy ones, like lodestone when you do your test on Monday. The only transparent one that you look through and it's going to be double is going to be calcite. So that's another kind of gimme one. And then if you want to open up your computers again, and go to kahoot.it. It'll be right here. So we'll go to. And once you get to Kahoot, go ahead and enter that game pin, that 823213. And once you enter the game pin, it'll tell you to enter a username. Go ahead and put whatever you want in there. Just make sure it's appropriate, because if it's not, we can find you. Go ahead.
Oh,
823213. Not working?
Yeah.
Here, let's see here. Technical difficulties. Here, let's try it now with that new game pin. 279722.
Yep.
That one's working?
Yep.
Alright, so you'll enter your username, then you'll come to a green screen that says got it, or ready, or something like that.
Got it.
Screen up.
We had 17, right? Yep, so make sure it's appropriate.
Hey, there's it. All the way.
Okay, we're waiting on one. Does everybody got it? There we go.
Yeah.
Alright, so has anybody done a Kahoot quiz before?
No.
No? Okay. So with this, once we push start, it's going to come up with a question up here, and you only have 20 seconds to answer it. You're going to have to look at the big screen here, because there's going to be 4 answers that have a color and a shape with it. And then on your screen, all you're gonna see is a color or a shape with it. So you're gonna have to correlate the answers from the screen with the colors on your page. And you get more points the quicker you answer.
Big fish.
Only if you answer right though. So get it right and get it quick and we're ready to go.
Wow.
So I'll read the question for you, then you'll be on your way. So which of these is a characteristic of minerals? Crystalline solid, formed by life processes, indefinite chemical composition, or organic substance? We got 11 seconds left. There we go. Correct answer is a crystalline solid. Most of you got that right. We know that it's not formed by life processes. It's an inorganic substance. And it's a definite chemical composition. It's not indefinite. So that was good. Ready for the next one?
Yeah.
Alright, ready? Okay. So whoever that is in first place, but
Who is
it is right behind. So,
Who is
it?
alright.
Who's anonymous?
The Mohs scale uses what to compare minerals? Cleavage, color, hardness, or luster? Got one left.
Let's answer.
7 seconds to click. There we go. Correct answer is hardness. Good job. Everybody got it right. That was great. Alright. Still got the same order there, although we got a tie. Minerals that break easily along smooth, flat surfaces have what? Cleavage, fracture, luster, or streak?
God, I missed that one question. Got me messed up.
There we go. Good job. I think you're the first class to get that one all right.
Oh, come on, 15.
So it's cleavage.
What is it?
15.
All right. Ooh, Lily took a jump ahead.
Big fish.
Ready?
Big fish.
All right. Which of the following minerals will pick up iron filings? Calcite, feldspar, lodestone, or quartz? Oh, that was a quick answer.
I'm in 6th now.
Correct. Lodestone.
Bees.
It's the only magnetic mineral you'll have.
I'm behind the bees.
All right. Quiet down. Lily took the lead now. Good job.
Oh, damn.
All right. Next question. How do you know that a mineral has crystals?
I don't know.
It's a tough one. It has a shiny crystal look. All minerals have crystals. You can see the crystals or you don't know.
I don't know.
It's a tricky one.
I just did.
5 seconds left.
Oh, I got that.
All right. Correct answer is all minerals have crystals. That's what makes them a mineral. All right. I think the last question here.
Last question. What? No, I'm in 6th. Keep going.
Lily's still in the lead.
It's
Oh, say
2 points.
Wherever you
All
are.
right. The Yellowstone mineral that smells like fireworks is what? Calcite, magnetite, sulfur, or quartz? That was a quick one. Wow. Good job.
I got
Sulfur. That's the yellow one we passed around. Good job. So you guys can go ahead and shut your lids.
No. Save it.
And it looks like Lily was the overall winner. Good job. Okay, so now if you guys want to take your sheets here, turn them upside down, and on the upper right corner, we're going to write some stuff here. Make sure you leave room though, because we're going to have a pretty big thing on the other side. What? There we go. So this is the mineral hardness scale. The hardness of common objects is what we're going to write in that upper right corner. So you'll write mineral hardness of common objects, and then fingernail 2.5, penny 3.5, and so on. And then this right here says quartz if you can't tell. Yep. So a fingernail is a 2.5 hardness. Your penny is gonna be 3.5 because it has some other stuff mixed in with it. Your iron nail is gonna be 4.5. Your piece of glass is 5.5. Your steel file, 6.5. And lastly, your street plate or your quartz, which you use more commonly, is gonna be a 7. The hardness of common objects, the one that's over there. Get it all copied? Out there at least? And so this stuff on the left side, that's your Mohs scale. That's going to be your minerals that it's using. What stuff that we use is on the right side, which is your common objects. It's the stuff you're going to have with you. We already talked about that.
Do you have fingernail?
Yeah. So gemsum is a 2, which means your fingernail's harder, so we'll scratch that. So we'll go over that in a second though.
Okay.
Is everybody ready? Okay, we'll go over to the next slide here. So now, across from where you wrote the common objects, on the upper left side, real big, do the field hardness scale. But leave enough room because there's 9 different points we're going to write. But this is a pretty important part. And all of this stuff we're writing and this whole page you can use in your labs and on your tests and everything. So it's pretty important that you get it written down. You ready? So, like we already kind of said, what's the hardness of our fingernail? A 2.5. So what's it going to do to talc, which is a hardness of 1?
Scratch it.
It's going to scratch it really easily. And if I take this graphite, it comes off my finger. So my skin is even harder than, so hard that it just comes off. So that's our first one that you're going to write down, is it's easily scratched by your fingernail, and it has kind of a greasy, soft, powdery texture to it. So if a number 1 can be easily scratched by your fingernail, what do you think a number 2 is going to be?
Still able to be scratched, but not as easily.
Yep, so since your fingernail is a hardness of 2.5, a 2 is still going to scratch your fingernail. It's just going to be a little more challenging to do it. So if I take this, which is a hardness of 2, and scratch it, it scratches, it just takes a lot of pressure. And you can hear it when Mr. Schild does it. You hear that? So it kind of makes that hard noise when you scratch it. So if a number 2 barely is scratched by a fingernail, what's a number 3 going to be?
Not going to be scratched.
Yep, not going to be scratched by a fingernail, and then what is going to scratch it, according to your common objects? Your penny, yep. So a hardness of 3, your fingernail can't scratch it, so I'll go through. It's not scratched by my fingernail, so I'll grab my penny, and you have to push kind of hard to make it go, but your penny easily scratches it. You see the white on there? So if a 3 is the penny scratches it, what is a 4 going to be?
Scratch mine everything.
So a penny's not going to be able to scratch it. So I'll try to scratch it with my fingernail. You always want to go through the process first so you don't miss anything. My fingernail doesn't scratch it, so I'll grab my penny. doesn't scratch it. The penny actually rubs off onto that. So then my next step is to grab my nail. So I'll take my nail, hear that? Easily scratches it. So what's next, do you think? Yeah, so my penny's not gonna scratch a number 5, and my nail isn't gonna scratch a number 5, but a number 5 isn't gonna scratch glass either, because glass is a 5.5, isn't it?
Yep.
Yep, so I'll take my 5, do my fingernail, nothing, penny, nope, my nail, nope. So then I'll take it to the glass, and the glass is kind of tricky because you can't test the glass in your hand, because even though glass is a hardness of a 5.5, it's really brittle, yeah. So you have to make sure it's on a hard, flat surface. So in the lab, you'll put it on your lab table, and here it kind of has to be here or the floor, because your desks, it'll kind of bend when you push it and it'll shatter everywhere. So I'll take this, and it doesn't scratch it. It actually kind of breaks off a little bit of the mineral here. So a 5 isn't gonna scratch your glass. So what's a 6 gonna be?
Scratch files.
Yeah, you're gonna be able to scratch glass, but barely. It's gonna take a lot of force. And then your steel file is gonna be able to make a scratch on your mineral. So I'll take my number 6, do my finger, nope, the penny won't do it, the nail won't do it. So I'll take it to the glass. Hear that? And it comes up, and you can see there's scratches all over that from this. So it scratches that barely, and then if I take my steel file, it's gonna leave a mark. All right, so number 7, what's it gonna be?
Street light or
Yep. So my mineral number 7 is gonna be able to scratch the steel file, because it's harder than the steel file. So if I take it up here, it kind of makes it, you can see a scratch, and it kind of makes it a kind of shiny looking thing up there. And then if I take topaz here, which is just this little tiny one, and scratch it, really easy to scratch this with topaz. So number 8, what do we think?
Let's scratch it.
Close. So number 8, the mineral barely scratches quartz, and then corundum scratches the mineral. So we'll take our number 8, which is topaz, and we'll grab our quartz, and the mineral barely will scratch the quartz. And then if I take corundum, which is our tetragonal one here, the corundum is actually going to scratch the topaz. It's kind of hard to see because it's so little, but you can see that there's little scratches on there. Number 9, any guesses as to what it'll be? The hardest thing? Diamond, yep. So your mineral is going to scratch topaz. So we'll take it. We'll scratch topaz with our corundum. Scratches it. And then if we take a diamond, which is in here, really little though, so I can't take it out, the diamond is going to scratch the corundum. And then we'll pass this diamond around. It's tiny just for you to see. Don't take the lid off or anything so you get lost. Got everything copied down? Cool. I'll have you, once you get that down, I'll have you open up your computers again. Before you do that, on your lab on Monday, to make it a little easier for you, there's only going to be 3 number 7s, so you might want to write that down. 3 number 7s, there's going to be no 8s, and there's only going to be 1 9 on your test. And then once you get that down, you can open up your computers again. And we're gonna go back to the pollev.com that's on that board. And we're gonna pop up with a new quiz. It'll just take a second though. Alright, once it gets popped up here, now push refresh if it's not not what's on the screen. So what you see on your computer should match what's on the screen. And then you can go ahead and answer it. The question is, what tools do you use to measure the hardness of a mineral? And those are your options there. It's 10 more, 7 more to go.
Come on, guys, you can do it.
2 more. Did everybody get theirs answered? So, what tools do we use to measure the hardness of a mineral? 82% of us said that we use our fingernails, pennies, nails, steel nails, glass, a steel file, quartz, topaz, or corundum to test it. This one is kind of a trick answer because the Mohs hardness scale are those minerals that we talked about, but we don't really use those to test the hardness of it. So this is the testing part. I'm glad nobody said their tooth. That was good. No teeth.
Wait, where was the tooth?
Letter A had a tooth in there.
Oh.
So, yeah, so that is all great. If you guys want to shut your lids again,
Are we gonna be using this?
your computers, nope. You can go ahead and actually put those away if you like. So shut them down, and then plug them in when you finish it.
Always